Thanks, everyone. I'm feeling the pressure now. I'm amongst distinguished company, so I'll just jump right in. Um, this is the message, my tagline: simplify the stack, maximize the potential. It's kind of what I'm trying to get across. And hopefully you'll see that as I go in. I'd like to start out an introduction by asking about you. I know there's one or two who are familiar with Elixir, but isn't it just a raise of hand, people who have coded Elixir? Okay, but I'm assuming some familiarity with coding because of this. Well, there could be some very new people. There's a little bit of code, but it's not going to be overwhelming. I can't really teach a whole language in 40 minutes. And then about me. This is a little bit true, a little bit false. The truth, I was a grumpy young man, and I like to think I'm a little bit more open-minded. So that's why I like to learn new languages. And in terms of the technical content of this, this talk, this would encapsulate it right here. That if you've worked on, or even just opened a web tutorial, you've probably used some of the tools on the left there. The Reacts, NPM, etc. That would be typical on a lot of projects. But really, you could just install Elixir, the top, the drop there, and Phoenix framework, and get pretty much everything you got on the left there. And that's what I think is really attractive about the platform. So in this outline, this is what I'm going to talk about. So what is Elixir? What advantages is it going to bring to you? Can it replace your existing stack, whatever it might be? And some of the challenges you might face as you're switching over. And then how can you get started learning Elixir? What is Elixir? It's a functional programming language. If you've heard about Elixir, you maybe know about that. I'll go a bit into what that is, but that's a big topic in itself. It's dynamically typed, but it's kind of a little bit enhanced in terms of just pure, simple dynamic typing. It runs on the Erlang virtual machine. Erlang is another language, and I'll talk a little bit about that in the history of the platform. And it includes this environment called OTP that brings a huge amount of power and capability to the language. And I think it's fun to use. So in terms of functional programming language, what do we mean by that? First-class functions. A lot of languages have that feature now. It wasn't always the case, but JavaScript would be similar in that case. So you can pass a function to another function as an argument. A function can return a function as its result. And same thing you can do in Elixir. It doesn't have to, but it often does feature pure functions. I think we heard that term in our last presentation. And the concept of idempotency. So that just means that if you give the same input to a function at 2 different times, you'll get the same output always. And if you want to operate on state, that state has to be passed in. There's no concept of an object in the way we have in Java, JavaScript, those languages. So if you need to operate on something, it needs to go in as an argument. Another feature is functional composition. Basically, it's functions all the way down. You build functions from other functions. There's also the concept of immutability, meaning that you cannot change data, which sounds a little bit more onerous than it is in practice, because I could reassign a variable name to something else. And behind the scenes, it's kind of replacing things. You don't need to worry about that too much. And another feature is recursion. I happen to love recursion, but I'm a bit weird. If you hate recursion, there's a good suite of MapReduce type functions that let you mostly avoid it. But it doesn't, Elixir doesn't have the type of for and while loops that you are probably used to in more procedural type of languages. And finally, this one's a little bit more obscure, but there's a declarative nature to Elixir. And that comes from its roots in Erlang, which was in turn influenced by a language called Prolog, which is a fully declarative programming language. What it means in practice is that you're more describing what you want to happen rather than very detailed of what you might do in C language or something of do this, then do that, do that. You can still do that, but it should make things a little bit more readable. So as far as a dynamically typed, this is what I mean. I don't need to explicitly, like I would in, say, Java, I don't have to explicitly say that my variable x is an integer or a string. And in fact, I could run those two statements in order and it wouldn't create an error. So I can retype a variable. But if I did this and then ran y equals x divided by 2, that could result in an error if I had made it a string. So you can get into trouble, but there are good ways of handling that type of situation. One of them is static analysis of the code. So there's a tool called Dialyzer, which comes from the Erlang world, which runs static analysis on your code. So it's going to point out if you do something like that. And there's also type hinting that you can implement in your language in the code you write. And also a more formal typing system is being added to the language. It's called gradual set theoretic types. And I'm not a computer science PhD, so I'm not going to try to explain that. But it is a formal system that's being introduced and gradually into the language. There already is a little bit has gone into the current version, which is 1.17, which gives you some warnings in a few cases, and more is coming. I'm not sure exactly how long it's going to be when it's fully implemented, but it's only going to get better. Now, I mentioned it's based on the language Erlang. Erlang is a language created by Ericsson. And Ericsson is a telecom company, was, I guess, was bought by Sony, and I'm not sure what they are now. In telecom, an outage of a switch can be tens of thousands of dollars a minute. And think back to 1986 when this was created. Telephone companies were making big money on long distance. Imagine if a switch went down and all that $1 per minute or whatever you were paying back then of all those connections went down. So uptime was of critical importance. And Ericsson decided the best thing to do was to create their own language called Erlang. So Elixir is based on the Erlang runtime system. But there is the term ERTS is the correct term to use for that. But you also hear it referred to as the beam, which is the virtual machine. So Elixir compiles to a .beam file. which is the same thing Erlang compiles to, and there are other languages, so it's all becomes interoperable. So I can call from my Elixir code something that's written in Erlang or one of the other Beam languages. And part of the whole runtime system is the OTP, which I've mentioned. This is a whole talk in itself. I'm going to slightly touch on a little bit of it later on.
I have a question.
Oh, yeah.
Is a Beam file kind of like the Java bytecode?
Exactly. Yeah, it's a bytecode file.
So it's cross-platform.
Yeah, it's cross-platform. It's not native code. This one is self-explanatory. Trust me, it's fun to use. A little bit of code. It's a functional programming language, so I thought I would start with a function. This is a very simple one. Returns true if a number passed in is false. Oh, sorry, true if a number passed in is even, false if it is odd. And you'll notice there's no return statement. It explicitly or implicitly returns whatever is the last value encountered in the function. One of the implications of that is that there are no early returns. So this type of thing that you might do in JavaScript to make sure that the value passed in is good, you cannot do that because I cannot return other than at the end of the function. We like to keep the functions short and readable, so that maybe won't be as onerous as it sounds, but I'll show you how we get around that. Another feature that you'll see if you start writing some Elixir code is the concept of pattern matching. So we normally think of the equal sign as assignment, and we kind of treat it that way in Elixir, but formally it's known as the match operator. So in the most simple case, the first line of code you see there, I'm assigning a variable, my list, to a list. So that's the left-hand side of the equal will match anything. It's just a variable. So that gets assigned. On the second line, now I'm essentially doing what you can do with, what's it called, destructuring in JavaScript. So I'm matching the structure of, in JavaScript, you have a map or an array, and you can pull values out that way. Same thing in Elixir. So this pulls out the first two values of the list and I'm ignoring the rest. And the third line, I'm just printing out the second value, which will be the number 2. And I can, see how we're doing on time. I can do much more complex destructuring. This is using a construct called a struct. It's a predefined map structure. Elixir also has maps, but this is, here I've predefined something called person. And I'm calling a function called fetchPerson, which presumably is going to retrieve a person record from a database or API. And this will check that it actually has the right structure. And then I can pull out the name of the person and print that out. And this will actually fail if it doesn't receive a properly formatted output from that function. Now, here's another function definition. This is, you probably wouldn't want to write this in JavaScript because it's kind of silly. But yeah, actually, this is probably a package on NPM, but returns true if a number is 0 and false otherwise. We do have constructs kind of like a switch statement in Elixir, but how would we do this a little bit more idiomatically in the language? This brings in a few other new features that I haven't mentioned yet about Elixir. First is a module, so it's basically a namespace. And then the function definition of 0 question mark. But you'll see there are two function definitions, and this is one of my favorite things in Elixir. Is some other languages have this, where you can have multiple function definitions, but this will attempt to pattern match on the number that is passed in. It'll hit the first one, and if it is 0, it's simply going to return true. If it doesn't pattern match on the first function declaration, it's going to fall through to the next one. And there, it looks at whether my number x, first of all, it checks if it's an integer. And if it is an integer, it will return false. This particular example is different from the JavaScript example because it will fail if I pass in something that's not an integer. And this example I pulled straight from the Elixir documentation. So you can see the results: pass in a 0, true. Pass in 1, false. Pass in any other data type, list or float, and it's going to be a runtime error. So I mentioned that there are ways to handle the different types. Kind of hinted at it on the last one using is integer. Here we have is number, and it's a guard clause to my function. So say I want to have another very simple, silly function that just divides by 2. This will first check that number passed in is a number and can be divisible by 2. So this avoids the runtime error, but it might get another error if I don't have a fallback clause to this function. And also, I mentioned type hints for static analysis. That's what the bottom part is there. So that at spec, that's called a type spec. And it's actually quite good in terms of the subtlety of errors. Often things that I don't realize, but when you look closely, you realize you could get into a situation where the wrong type gets to a function. And another feature of Elixir is the pipe operator, and this has almost become a second logo for the language. So it's the pipe and the greater than symbol. Here's a case. I want to take a string and I break it up into separate words and make everything uppercase. So I won't even try to explain this. You've probably seen something like this, a function and a function and a function in other languages. And it's very ugly and hard to read. If you were writing better code in most languages, you might do something like this. So first, I turn my input into uppercase and assign that to a variable, uppercase input. And then I split it based on where the space character is. So it'll break it up into 3 different things. And then I just use an inspect statement to print it out. So this is valid Elixir code. This would work this way. But if we use the type operator, we get this. And I just think that looks good. What the pipe operator does is it takes the left-hand side of the pipe operator and injects it as the first argument of the function on the right-hand side of the pipe operator. So I'm passing my input variable, as the first and only argument to my uppercase function. And then the result of that is being piped to the split, which splits on a space. And then that output is being piped to my inspect statement, which is basically console log if you're a JavaScript programmer. It can make for some pretty interesting code that just reads as almost like a set of comments if you're naming your functions properly. So some of the advantages of Elixir, I would see these as being, first of all, the community, because you might have encountered some communities online that are kind of not very inclusive and or maybe even a bit hostile to newcomers. Definitely not Elixir. The scalability, very interesting the capability you can do, and fault tolerance, what happens when some of these functions that I've mentioned fail, and a rich ecosystem. So even though it's a newer language, you're inheriting all of Erlang, so there's a rich set of packages that you can build on. As far as the community goes, it's a lot more than 2 people, but I want to highlight these 2 guys. Jose Valim, a Brazilian programmer, creator of the language. He has a Ruby background, so you see Ruby's influence on the syntax of the language. And Chris McCord, he created the Phoenix framework, which is the API web framework and probably the most widely used package in all of the Elixir space. These guys, you can make a comment on Reddit or in the Slack or on Elixir forum. I have a link to here. And they just pop up like magic. You think they probably have clones, or maybe they have an AI bot that is watching for this stuff, but they're very accessible. And there are other people like that in the community who are behind other projects as well. Scalability, this could be another presentation just in itself. The strategy that Elixir uses to become highly scalable is it uses lightweight, isolated processes that can run concurrently. So I could have a bunch of different things working independently, and they communicate through messages. And I realized watching our previous presentation that I missed a huge opportunity. I know I was following you, Juliet, but this would be perfect for implementing a state machine. The message passing, so essentially an event, and these isolated state, you could have many state machines or a single one, a single source of truth for the entire system. And it's also an implementation of the actor pattern, message passing and isolated processes. What it has made possible is that you can write a fairly simple system, a fairly simple component, and run it many times over concurrently, run it across multiple nodes, even geographically dispersed, although you're still limited by the speed of light and all that. And WhatsApp does not use Elixir. As far as I know, they use Erlang, but it's the same virtual machine. They have been able to achieve, I think I've heard 3 million concurrent connections. It uses, yeah. So it's connecting over TCP. I'm going to talk a little bit about WebSockets. That's incredibly easy to do without even knowing anything about WebSockets. The next thing is fault tolerance. Again, thinking back to Ericsson and them being a telephone company and uptime being critical. One thing you'll hear in the community is the mantra of let it crash, which sounds kind of scary. It's not really that scary. It's actually good news. What it means is things can crash and it can handle it. And I have a real life example of that in a project I worked on. We had essentially it was a form that you could enter data in, and when you hit save, it crashed the entire process. But because of Elixir and the way things work, we didn't realize there was an error. The team I was working on, we didn't realize there was an error until we were checking the logs. Because what would happen? It would save successfully, but there was an error in handling the message back with the results from the database. What would happen is it would crash the process that was running the form, but it would automatically fall back to the previous screen, which was kind of a list view, which was the desired result anyway. So the only perceptible difference that there was an error here, other than looking at the log, was there was like maybe a half-second delay as it spun up a new process. Pardon? It was a feature of Elixir. It was a bug in our code. So it does this using the supervisor, which is one of the things that inherits from OTP and Erlang. It's basically, rather than extensive error checking and did this return the right thing, what it does is it monitors the process and quickly restarts it if you set up the right strategy. These are all options when you set up a supervision tree of processes. And everything is isolated, so the things are less likely to interact. I'm sure you can create a race condition, but compared to, like, I've worked with Java and doing like the synchronize thing. It was always very complicated, and we would often run into bugs with that. And another thing that from the telco world is hot code swapping. It's maybe less relevant where you're just running Kubernetes clusters and you just spin up another node, but you can update the code on a running server. Just swap it in, and it's going to gradually switch over to the new code. If you're running a telecom switch, that's a desirable thing. And I think I lost a heading here. Oh, there we go. Interesting. Talking about fault tolerance. I didn't plan that. So I mentioned OTP. That's managing all the processes. It also includes more tools that I can mention. One is what's called ETS, in-memory database. So you could replace Redis with that. Phoenix and LiveView, that's the web framework. Livebook is a live code notebook, kind of like Jupyter Notebook, Google Colab. So you can write live documentation that you can interact with and run the code. There's a package archive online. And I'm just trying to speed up a little bit, so hopefully you can get some questions at the end. Can you replace your existing stack? So refer back to all those logos I had early on in the presentation. Here's an example of like one-to-one what you could do. The first, if you install Elixir and Phoenix Framework, you're going to get the, well, the first 6. Those are all going to be built in. So one-to-one, you could replace Node.js. There's the, it's not object relational management because there's no objects, but it's for accessing the database called Ecto. Live view is kind of a weird combination of like React, but you can write server-side code, but it runs on the client essentially like you would a React app. I'm kind of oversimplifying it, but it's using a kind of a transparent WebSocket connection so that if something changes on the back end, it will be immediately reflected on the front end if you're handling those messages. And I mentioned you could replace Redis with ETS, and there's tools for either writing your own queuing system or interacting with Kafka, RabbitMQ, those types of tools. Now, I wanted to give a very quick story. So imagine the North Atlantic, 10 minutes, and at the end you hold up a score, right? Okay. Imagine the North Atlantic 100 years ago, back before all the modern radar. Junior officer on the deck, watching out for anything that could go wrong, manning the helm. And he sees up ahead this. He runs to get the captain who's having dinner. He says, Captain, we've got this insurmountable obstacle. The captain says, sailor, there are no such things as obstacles, only opportunities. Captain, we have an insurmountable opportunity. So I renamed this as opportunities, trying to take a positive spin. So Elixir is dynamically typed and doesn't have the type safety, but as I mentioned, they're adding the typing system, and you can already do static analysis that is quite good. Not as sophisticated as, say, TypeScript, but we're getting there. This one, if you're used to using arrays, there are not arrays in Elixir. There are lists, and that's a linked list and has all the advantages and disadvantages of singly linked lists. But there is, Erlang actually does have an array module, and you can call that directly. That's overcoming our obstacle. And there are packages in hex.pm which wrap that. And for if you want to do matrix math or machine learning type stuff, tensors, there's a new package which will run large-scale calculations on a GPU natively in Elixir. And language servers. There is not a good language server. There are 3, but it's kind of a fragmented landscape. A language server, if you're not familiar, is in VS Code, where you start typing and it already knows the APIs and has looked at your code and can give you an autocomplete with the right types. So the core team is working together to have something available to make that possible. Working with the maintainers of the 3 language servers to have an official one. So how can you start using Elixir? You've done the first step. You've attended this. You could join Montreal Elixir if you're not already. As always, build something. Coding Kata's Leet Code, and coming up December 1st is Advent of Code. Great way to learn a new language. There are courses available, books. I'm gonna cut it off here because this is available online. It's through, people should be able to access this through the conference website. Okay. And I just wanted to finish up, and hopefully we have time for a little bit of a question Q&A. But if you walk away from this and say, wow, Elixir sucks, I'm going to go learn Rust, I've done my job, because I want you to get outside of the box. If you ask for career advice 50, 55 years ago, they would have said, learn IBM. 35 years ago would have been, Microsoft is the way to go. Today, I don't know, AI. Do something different. Do what you want to do. You only have limited time here. At least do some of what you want to do. Learn something new, something outside of the box. It'll make you a better programmer and a better thinker, and it'll make you better when you get back to your real job. Thank you. And also the feedback if you want to do that. Any questions? Yes.
Have you ever built anything with the new kid on the block, Gleam?
No, I have not used Gleam. Gleam is another language that compiles to the same bytecode. It looks cool though.
Like type safety?
Yeah. Oh yeah. It brings in type safety. It simplifies a few things in Elixir and removes multiple function definitions, which is one of my favorite features. So I don't know. Yes. It's fairly, well, I mentioned lightweight processes. It's going to depend. If you have a large set of state for tens of thousands of users at once, it's going to use that much memory. If you have things if the processors are in memory, or you could be, moving things in and out of secondary storage. But the process itself is, you're looking at a fairly small amount of memory. I did have some figures I forget, so I won't try to. Yes.
I just wanted to know if OTP is it like a process of the data, and does it can it be compared with like Kubernetes?
So OTP, is it like Kubernetes? It's a whole suite of things. So it does manage the processes, so it can start and stop. It has something called a gen server, which is a way of communicate, a behavior for communicating. But it does a bunch of other things. I've seen Elixir used with Kubernetes as well. So we would have our application running on multiple pods. So it's complementary as well.
If you run on Kubernetes, how would the messaging look like? Because you mentioned that OTP was handling processors and handling messages with processors. So but how would it work with
you can, by addressing the different nodes, and presumably you would have some sort of directory of nodes if you need to talk to different ones for different purposes. I have worked on the Kubernetes type projects. I didn't get too deep into that part, so there's probably a better answer out there than what I can give. Oh yeah, definitely. Even across geographically dispersed applications. Yes. Yeah. it's a pretty common pattern to return a structure like with the OK or error. So generally what's done is a pattern matching approach. So you would have different function handlers. Often it would be a message passed from the back end and then an event handler essentially that's going to look for OK and then follow the happy path there. And if it's an error, then try to do some error handling. Yes.
You said the function were pure, but can you describe that the function as a side effect? For example, like fetch person as a side effect?
Oh yeah, not everything has to be pure. I mean, you can't really do any real world things without some kind of side effect, really. So it's not purely academic. So you can write to the database. You can interact with hardware. No, you don't have to formally declare it that way. But when you are able to break it up into your code into pure and impure functions, that makes the testing of the pure side, at least, much easier and much more complete. I think we must be out of time.